So last session for today. I think you're already pretty exhausted. So I hope we get through. So that was our text editor. So in the normal lab, there are some optional tasks to add some support for printing and to use a dirty flag. So to identify that the text within the editor has changed. So feel free to do this as a little homework. Okay. So next topic would be application settings. How can we store settings of our application? So in one of the previous slides, we already had the properties to set the organization name or domain and the application name. So this is pretty important for the Q settings. And normally you would like to make your application that it appears at the same position when it was last closed. So therefore you can use the Q settings clause to store all the settings. So in this example, we have a group and a value, and the set value function is used to store it, and the value function is used to get it back again from the settings. So how is this stored on different platforms? So normally, all these settings on Windows go into the system registry. So here is some functionality to set the window position and the size of your main window. So in the write settings, you set everything, and in the read settings method, you read out everything out of your registry. So based on your application name, this is located under HKey local user or current user software, and then your application or your company name, and then your application name. So that is how it is done on Windows. On Unix-based systems, this is using INI files, and on macOS, this is CF Preferences API. But for you, as a developer of Qt applications, you just have to deal with the Q settings object. So this is completely transparent to you. So there's also the scope you can define, whether you can make it system-wide or user-specific settings. So under Windows, this is HKey current user or HKey local machine. So the usage of Q settings is pretty simple and it's very cheap. So you just have to type in a few lines of code to save and restore all your settings. Coming to the next feature of applications, and we would like to store our pixmap or icons, translation files, sounds in our executable itself because we do not want to deploy it. So how do we do that? We can use the Qt resource system to add these resources. So within Qt Creator, we just go to our main window demo again, and we just say add new Qt resource file. So once we have done that, we see that we get a new resources file with the suffix .qrc. So once we take a look into that, it's empty right now. We have to add a prefix. So we just add a new empty prefix. And then we are able to add some files to it. So let me see if we have some nice PNGs. So now it asks me, so this resource is out of tree, out of the directory, so it asks us to copy it to our project. Okay. So we add it to here. And now we see that we have an exit pix map added to our resources. So let's save everything. So let's try to put this resource to our action exit. So now choose a resource. Oh, again, this is out of screen.
You can try to change your settings to just one monitor to have.
Yeah, normally it is, but somehow it's out of screen because I
have the same situation because I have normally two screens and then it's somewhere.
Okay. No. Just one moment, let me. Yep. Yeah, it's just a single screen, so let me. Ah, no, I cannot enter it in here. It's. So let's try the following. Okay. No, I'm not able to enter it, but normally if you try this on your machines, you should see this resource selection dialog where you just select the exit PNG and this PNG will appear within your application. Oh, it's called application.exit. Okay. Let's try. Okay. Application. No. Sorry. Yeah.
Is that the drive level missing?
No.
The left side of resources?
No, that is. But let me just try. No, it was not. I now try to tweak it from within the UI file.
Is it correct, a double point? And then
Yes, this is something which specifies a resource. No. Okay. So the resources are all located in the QRC file, and you specify a resource name to access the resources, and with the colon you specify that this is not a regular file, it's a resource file. So everything which begins with a colon is a resource file. So, and that's pretty nice. Whenever you try to deal with a file within your resources, you just specify this colon. And you can also say file open, and if you specify the colon, Qt is trying to load this file from the resources. Oh. Let's try one more thing. No. Doesn't want. Okay. Okay, so then you can specify some prefixes. So let's say if you have hundreds of pix maps within your resources, you can just bundle your icons into different prefixes, and you have to specify these prefixes also in your resource path. You can also specify aliases. So if you would like to have an alias cut.png, which is reference to the image's scissor.png, you can directly access it through this alias name cut.png. Okay, for all the resources you have added to your project. This means that all the content of your QRC file will be recompiled into your binary. So whenever I try to recompile, you will see in your output window that it tries to compile the QRC file first. And this is going to translate everything into some binary data which will be linked into your binary. So whenever you see this QRC underline main window, that is your resources. It's also very nice if you like to access your resources. You can treat the resources as a normal directory using qdir to the :/. So then you get the directory of your resources. Just as a normal directory. Okay, so let's try to translate our text editor for multi-language support. So internationalization, or the abbreviation is I18N, because it's 18 characters in between the I and the N. Our localization, it's 10 characters between L and N. This lets you, gives you support for multi-languages. So you might have seen that in the source code I typed in, I added a TR function. So this TR function is the marker so that a string gets translated. So everything which you do in the Qt designer is automatically translated and enabled for multi-language support. So coming back to our UI file. So let's add a push button. So if we take a look at the push button, it has a text property. And the checkbox translatable is the identifier whether this text is enabled for multi-language support. So by default, all the texts are translatable. So you can also specify some command for the people who translate your texts. So you can say, treat this push button in the context of this action. So how can we add these text translations? So there is different tools available within Qt to do this translations for us. So the first one is lupdate, which scans all the C++ files and UI files for text. And then there is Qt Linguist, who lets us edit the TS files, the translation files, so that a translator can translate all the texts. And then we have it lrelease, which converts this readable TS files into binary QM files, which we normally deploy with our application. And here is the translation process in detail. So let us try to add some translation support to our text editor. So we are going to our profile, and now translations plus equal, yeah. So let's create a German translation file. Okay, so now we need to scan all our texts within our application. So, and therefore we can, let's see if we have this external tools. There is external tools for linguist available, lupdate, which we call right now. And now we see in the output window that it has found 8 texts to translate. And we can have a look at these translation files using Qt Linguist. So, lupdate has found 8 texts. Main window, file, open. This opens a file. Control O, close, exit, and open. So it will also show us the place where this text has been used. So main window is used as the caption of the main window. File is used in this menu. So we can add a German translation for that. So, and we can mark this text to be translated. So later on, when we look into this, we will see that the main window is fully translated. Okay, so we save these files, and now we can convert this into a binary form using the lrelease tool. So lrelease now tells us that it has generated 2 translations, 2 were finished, and 6 translations were ignored. Okay, so if we take a look in our directory, we now have an app_de.qm file, which is the binary representation of this XML-based TS file. So we have done the lupdate, we have generated the TS file, we used Qt Linguist to fill the TS file with translations. We have run the lrelease to generate the binary version of the TS file, and now it's up to us to load the correct translation file into our application. And therefore we have to add the right translator. So we go back to our main function, We include the Qt translator. We load it, and we install the translator within our application. Okay. So now let's, there's, I don't think it will work. Yeah. It's because we are now running our application in a shadow build directory. So by default, the shadow build is activated within our project. So that means our sources are located in a different tree and our binaries are located in this. So what I will do now, I copy the QM file and place it in our executable directory where the binary is located. Still doesn't. So now let's try to debug it. Okay. So it fails to load the translator. I think this is due to the path is let's just try to tweak that. Okay, so now it's succeeded loading the translator and it's able to translate our application. So what I would normally do is I just adjust the right paths here to run it correctly. So it's no good solution to put in an absolute path here, but just to show it to you. And then we see that all strings will be translated in the right language. So what you have to do in general, you have to specify all the languages you would like to use, adding the translations plus equal into your project. Then you run the L-update to scan through all your sources. And then you give, let's say, the German translation file to a German translator, the Russian translation to a Russian translator, and so on. You get back all the filled translation files, convert them to QM files, and load the right translator in your application. Any questions?
How do you handle text not directly related to widget, like some other messages?
Okay, the question was, how do we handle global texts? So what you can do is in your Qt linguist, you can specify the context where the text belongs to. So, and if you don't want the context to be the main window, for instance, you can generate a new context, and instead of using the tr function, you can just specify the translate function of the core application where you can specify the context. So the context is used to specify the group for this. And if you have a global context, you just have to use this translate function and specify your global context. Okay, so what you can do in practice is you can go through the directory where your translation files are located, and you can scan through all the files. You can just extract the suffix underline DE, underline NL or EN, and identify the languages, build up a menu for all available languages, and then the user can dynamically select a language from all the available languages at runtime. So language change at runtimes will generate an event, language change, on which you can react. So whenever a language change comes up, you can retranslate your UI files so that all the texts within your UI get updated. Okay, then there are some additional things you have to remember when you deal with multi-language supports. You have the different locale settings, meaning if you have a decimal point or a comma. And here is the API functions to use the QLocale. So then there is lots of conversion functions available in QDateTime to handle date and time formats, different date and time formats. There is an additional format specifier in the toString function where you can exactly tell in which string you would like to convert a date. Then you can specify different resources for different languages. So let's say if you have a PIX map with some text inside the PIX map, you can specify multiple PIX map for different languages. And of course, Qt also handles the different key sequences. So let's say the Control-N for a new file is on a Russian system, some other key combination. Okay, so that's the translation of the editor we have just done. So what does it mean if we like to deploy our Qt application? So there's different ways of deploying or linking. So if you're using standard or static linking, then everything is compiled in a monolithic binary, to which you just have to deploy. So you have only a few files, but they can be extremely large and extremely inflexible. So the better approach is to use shared libraries, but that means you also have to deploy these shared libraries. And then these libraries can be shared among applications. So, and then you have to take care that the path for your shared libraries match, so that the executable will find the shared libraries at runtime. So the easiest thing is that Qt is pre-installed on the system, and the system is able to locate the shared libraries. So you just have to deploy your executable. But then you also have to take care that the correct version of your libraries and executable are deployed, everything is matching, so that the executable will run properly. So, but if Qt is not pre-installed, you have to redistribute the Qt libraries and all the plugins used by Qt. So if we take a look at our Qt installation, so let's take a look at 473, you will see the plugins directory, and there is additional plugins located in here. So, and the tricky thing is that, for instance, you have an image format for JPEGs. And on your development system, everything works fine, but on the target system, it doesn't work. It could be that you missed to deploy the JPEG plugin. So take care that all the plugins are also deployed on the target system. So it's the same for SQL drivers, for different graphic systems, image formats. And that's the most important things you might miss in deploying your application.
If you have a plugin missing from your target system, do you get a helpful error message telling you which plugin you have missing?
Pardon?
If you have a missing plugin from one of your target systems, does the error message that you get tell you which plugin you're missing?
Not really. In the case of a missing JPEG plugin, you just do not see the JPEGs, and it's really, it can be time-consuming to find out that it is a missing plugin. Because on the target platform, you normally do not have any debug output window, nothing. So it's just not there. So, not always. If it's statically linked into the Qt DLLs, it will find it. But some of the plugins are loaded dynamically at runtime, and then the dependency worker will only find it if you, how is it called, attach the process and run the process and execute it. Do you know how to do that? Normally, if you start dependency viewer, you just get a list of statically linked libraries to your DLLs, and it says this one and this one is missing. But if your executable tries to locate a library using load library function, it does it at runtime. and then you have to attach to the process and run the process in dependency viewer.
So it means that I can generate a static one and it still not works. Can I run in the situation?
You mean if you have a static version of Qt, normally you configure the Qt so that these plugins are already linked into your libraries. But yeah, if you miss that, it might not work.
Do you have a tool that helps you determine what libraries are needed to deploy?
Yeah, in Windows, it's the dependency viewer.
In your eventual installer, how do you determine what libraries do you actually need to install?
You mean installer program?
Yeah.
Normally, if I'm running on Windows and I'm using Microsoft compiler, there is a setup and deployment wizard, which automatically resolves the dependencies. And it is able to create a package, an MSI package, where everything will be installed correctly. But that really depends on what kind of installer you're using.
Is there a tool that can generate a list of what files, libraries, DLLs needs to be?
No. The question was, is there a tool to identify which libraries are used? Because this is really platform specific. On Linux, you can use the LDD to resolve the libraries. But there's no Qt built-in tool. One other option to see what libraries are used is that you run your application within Qt Creator and look at the modules which are loaded at runtime. Okay? Okay. So, coming to the last chapter, which is Dialogs and Designer. So, Designer we already know about. So, let's take a look what dialogs are already built in Qt, and we already saw some of them. So, the base class for all dialogs is QDialog. So, whenever we try to make our custom dialogs, we will inherit from QDialog. Or we can use some predefined dialogs like the file open dialog, which we have already seen. Or we can use Qt Designer to generate our own dialogs. So there's two different modes of showing a dialog, and I think all of you know about modal and modeless dialogs. So a modal dialog will be opened and stays on top until the user has pressed OK or cancel and the dialog disappears, and then the input control is back to your application. Or you can have a modeless dialog where the user can interact with the dialog and your application at the same time. So modeless dialog does not block your application. And Qt Dialog is able to handle both modal and modeless dialogs. And the example to show a modal dialog is that you just call the dialog.exec function. So it's very similar to the main event loop of our Qt application object. It just runs an event loop of this modal dialog. So the program will stop at this line until the user has pressed OK or canceled. So modeless dialog is just created with the new operator, and it's shown on the screen, and your program execution will immediately go ahead. So in this case, we just create a new find dialog, we show it, and the program immediately goes to the raise, which brings the window on top. We activate the window for the keyboard focus, and the find method will finish. And our dialog is still shown on top. So the program will not block. So to know about what the user does, we can use signal slot connection to identify when he tries to find the next, that a signal is emitted which we connect on the onFindNext slot. Okay, so let's take a look at how to create our custom dialogs. And coming back to our main window example, let's just add a new designer form class, and we specify a dialog with the buttons at the bottom. We can just give it a class name, a corresponding header and CPP file will be generated. So no source control. So that's it. That's our new dialog. It just has a dialog button box at the bottom with an OK and a cancel button. Okay, so there is two ways of closing the dialog, whether the user can press the OK button or he can press the cancel button. Or the third possibility would be that he closes the dialog with the X button in our window decoration. So that means if he is pressing the OK button, the dialog gets accepted. If it's closed with the cancel button or with the close button of the system menu, it gets rejected. So that's the way how you should handle dialogs. You should not say if cancel button is clicked, because it could be closed by the system menu with the X button on top. Okay, so when we talk about modeless dialogues, we have to think about the lifetime of a dialogue. We just bring it on top with the new operator, and this stays on top until the user closes it. And then we have to take care that the QDialog object gets deleted correctly. And the easiest thing to do that is to set the attribute QWA delete on close. So whenever the close button or the dialog is closed, it automatically deletes itself. And you will not have a memory leak. Okay, so let's take a look at some predefined dialogues within Qt. And we already know some of them, the open file name. There is a version where the user can select multiple files. And there is a good example to demonstrate this functionality. So starting again, our examples and demos. Launching the standard dialogues. So this is an overview of all the built-in dialogues in Qt. So to get open file name, we already know. Open file names, I can select multiple files. So it returns a list of file names. There's some additional helper dialogues to get an integer value, a double value, an item from a combo box, just a user-defined text, a color selection dialog, font selection, get an existing directory. Okay, open file name, save file name. It's message boxes. So this is an example of a message box for a critical error. Information boxes with an information icon. Question boxes with a question mark. Warnings. And finally, you have a Q-error message where you can just bring up an error message and show this message again, checkbox. So normally, all these functions are using the native dialogues. So that means on a Windows system, Qt is using the Windows dialogues, and on a Mac system, it's using the Mac dialogues. So if you don't want to have this behavior and you want the dialog look always the same, you can unselect this use native file, and then if we open the file name, then we get the Qt version of a file selection dialog. And this looks the same on a Windows as well as on a Linux as well as on a Mac system. Because the tricky part about that is if you're using the system built-in dialogues, and I show you that again. So this dialog is system specific and it will use the system language. So right now you see that I have a German set of buttons and I'm not able to change this behavior within Qt. So if I would like to translate these dialogues as well, I don't have to use the native dialogues, I have to use the Qt dialogues, which I can translate with Qt Linguist. Okay, so here we see all the APIs functions to get these common dialogues, the API for a message box, for a progress dialog, where you can just show up a progress bar and some text to it. The error message, all the common dialogues to enter text or an int or double values, colors or fonts. So that's all the pre-built-in Qt dialogues. So whenever you like to implement your own wizards, just keep in mind there is a QWizard class which you can use. So you can define multiple wizard pages, implement the navigation from one page to another. So I don't want to go too much into detail. I think the usage of modal and modaless dialogues is pretty clear. Modal dialogues, when you just want to block your application and wait for a user input, and when the dialog is closed, you can control your application again. And modaless dialogues are just, the user can use these dialogues as well as your main application, and it does not block. The exec function is called for modal dialogues, and the show function is called for modaless dialogues. Can you bring up a modal dialog when a modal dialog is already active? Of course you can do that. The Windows operating system is full of modal dialogues. You have maybe TCP properties, then you click on advanced, you get a new dialog, and then some extended properties, and then you have to close all these dialogues to get back. Okay, when do you need to keep the widgets as instance variables? Normally, Qt Designer does everything for you and keeps the variables for you. So what is the problem with this code? The code just creates a dialog and creates a checkbox within the dialog. So actually speaking, the code would work, but it's really bad coding. Normally, you just subclass from Qt dialog and implement a checkbox within your dialog, and you do not call it from the outside. Okay, another lab, which we skip. So the last chapter is a summary of our Qt Designer again. So let's see if we have discussed all the functionality. So Qt Designer is the graphical tool to create user interface files. So we have already seen how to add actions, but what we didn't see right now is the signal slot editing within Qt Designer. So let me just show that to you. Let's close that. Okay. So when I would like to have some signal slot connection, I can do the following. Let's say I convert this push button to a toggle button, just enabling the checkable property. By default, this is checked. And then I would like to do some signal slot connection with the state of this button. So let's say I just add a group box, which I'm going to enable or disable. So let's put some radio buttons. Within the group box. And now I go to the signal slot editor. So which is this button here, edit signals and slots. So now I'm in a different editing mode. You see that the highlighted elements get red. So now I would like to just to connect the push button with the group box. And push button toggle signal should be connected to the set checked of the group box. So right now we do not see a checkbox because the group box is not yet checkable. Okay. So let's try to preview that. So you see if I press the push button, the group box automatically gets checked and unchecked because we have a valid signal slot connection. So and that's done without a single line of code. You can do that, of course, from source code, but you can also do the simple connections within Qt Designer. And you see all the signal slot connection in the signal slot editor. You see the sender push button and the signal toggle is connected to the group box set checked slot. Okay, tab handling. That is also important when you try to navigate through your dialogs with the keyboard. So when the user presses the tab, you can set the tab order. So first of all, you have the text edit, then the group box. So I can rearrange the tab order and then I can run it. And you see, now the tab is consumed by the text edit, but here, I can just specify what happens on the tab key. Just for your information, it's also possible that you create your own custom designer widgets. So if you like to have your own set of widgets, you can create a custom designer plugin, copy it to the specific location, and it will appear in your toolbox here. So there is a good sample available for that. Which is the analog clock example. Just an example of an analog clock which you can add to your designer. Okay, I think we already had most of the views. So one thing which we didn't have is the object inspector. If you want to have a look at the hierarchical structure of your user interface file, you can just take a look at the Qt Object Inspector. So the main window has a central widget, a menu bar, a main toolbar, and a status bar. And the central widget has a grid layout indicated by this icon here. And within the central widget, we find our group box, the plain text edit, and the push button. So with that, it's pretty simple to navigate through your user interfaces. You just click on it and set the properties for this selected element. Okay, the body editing is something which you need when you want to handle the keyboard focus correctly. Let's say you have a spin box with an edit field, a plus and a minus key, so that when you press the key, the spin box behaves correctly. So finally, all the UI files are translated again with a user interface compiler called UIC. So whenever we recompile our application, we go to the compile output, we see that UIC converts this .ui files, okay, and generates some UI underline classname.h files. And this is the source code which Qt has created from the user interface files. So whenever you're interested in how does Qt Designer do that, just take a look in the source code. So in here we see the process for this UI files. Qt Designer saves the UI file, UIC compiles it into a UI underline something .h file, which will be included into your class files. But keep in mind, whenever you add a new designer form, Qt Creator generates a UI, a CPP, and a corresponding header file for you. So, and this is the important point, how to add designer forms. Just add a new designer form class to generate these three files. Okay, so every object within a UI has a unique name. So whenever we have a widget in here, we can specify this a unique name. Okay, just call it my radio button. Save everything. So now when I try to access this, I can use this object name to identify it, and I can just set the text for instance. So this is now set to my text. So this is the way how to access the controls from a UI file. So the layouts we already had. You just select the items and say layout, or you just click on an empty space of your main widget and say layout horizontally, vertically, or in a grid. And I already showed you how to nest the layouts using these layouts here. Okay, we know about the preview mode. If you are interested on how this looks on different platforms, you just might want to show your application in a different style. So this is how it looks on Motif. And we see that the implementation within our header file is just go one slide back. Where is it? Here. In this slide, we see the UI underline something.h file, which is included in our header and CPP files. So when we take a look at the implementation, we see that the My Dialog, for instance, so that is the implementation on the header side, and on the CPP side, it includes this UI underline file so that you can access it. But normally, Creator handles everything for you. You don't have to care about that. Okay, we had already the signal and slots. And if you follow certain rules, everything is done automatically. So if we take a look, for instance, I just add a push button. I say go to slot, and I would like the signal clicked. Automatically a slot is created on push button clicked. So this follows certain naming conventions. So if you have an on underline, then name of your object, underline, name of the signal, this will be connected automatically. So there is no connect function needed to connect that. So don't get confused because there is no connect function called. This is an auto connection which is done following a certain naming convention. And the naming convention is on underline object name underline signal. Okay, there is another way of using custom widgets in Designer. I already showed you the analog clock, where you can implement a Designer plugin, but there's also a chance to promote widgets. So you can say, this is actually not a queue frame, this is my frame or my widget. But normally you don't do that. And dynamically loading of UI files, I've never seen a customer doing that. In theory, you can dynamically load the UI files so that you can change them. And then you can access all the widgets in this UI file by name using the Q file child. But this is very tedious work, so I cannot imagine that someone wants to use that. So this is another lab exercise, how to implement a designer form. Pretty simple one. So that's the end of today's session. I hope you enjoyed it and you keep all the information I told you, and from Thursday on you go and practice what you saw today. Any final questions?
So yes, I have a question regarding remote access. Is it possible to create an embedded Qt application that can be viewed remotely? I mean, is there something like a VNC client or Windows terminal client that's independent of an OS? Maybe?
Yeah, you can feel free to use VNC. So that is always a solution. There's no pre-built functionality within Qt.
Yeah, if I want to use VNC, the assumption is that my Qt application is running on Windows. But if it's an embedded target, so my customers are writing, for example, industrial control applications.
Yes.
And they are embedding them, so there's not necessarily a VNC server running. So there's nothing in Qt that enables remote display.
Yeah, you can do something on the embedded side. Maybe tomorrow you find some time to visit our booth. If you're running on embedded, you can use QWS window manager.
Okay.
And there is also a way of using VNC a client to access the QWS embedded windowing system.
Sounds interesting. Okay, thank you.
Just ask my colleague tomorrow. He has done that on the embedded side.
Great, thanks.
Any more questions? Okay, so let's close the session today. I hope you enjoyed it all. Even without the labs, I hope that at least you heard something and you know what to look at. Okay.